So today what we're going to attack, kill, and destroy is we're going to look at 4 properties and the definition of parallelograms. So they have to do with angles, and they have to do with sides, and they have to do with diagonals. So by first, a parallelogram, and by the way, here's a super secret shortcut to write parallelogram because that's such a long word to write, and we want to be efficient. Just draw this little puppy every single time. Ka-chow. There you go. Now you're saying parallelogram. Just like triangle, you can draw this, talking about a triangle. So, mathematicians are brilliant. So a quadrilateral, quad, it's a 4-sided figure with opposite sides that are parallel. Hence the name parallelogram. All right, so with that in mind, if we want to explore parallelogram, notice again the key feature here. We are going to use congruent triangles. Without congruent triangles, without triangles, we would not be able to prove everything else. Remember, yesterday's theorem was completely based on triangles also. Okay, so ABC is a parallelogram. Definition of parallelogram, that we have 2 pairs of parallel. Remember, as you go, mark the parallelogram, mark the congruences. That's going to help us determine, especially when we get to side angle side or angle side angle or whatever the case may be. All right, now why do we know certain angles are congruent? Angle 1, angle 4, and then 3 and 2. So if we look here, why is angle 1 congruent to angle 4? And why is angle 2 congruent to angle 3? All right, so here, the reason for this is because of parallel lines, alternate interior angles are congruent. You could have also said the alternate interior angles theorem, or sometimes it's called the alternate interior angles postulate, thanks, angles. All right, next, what else? Reflexive property. Oh, we know that AC is congruent to itself, which you could have marked with a single. So come back here, AC is congruent to itself. Now, why are the 2 triangles congruent? That's going to make me dizzy. Angle, side, angle. Angle, side, angle. So now we know what? We now know that what we're trying to prove is true. So notice originally on step 2, I wrote the symbol parallel for the exact same sides, BC, AD, and then AB and CD, but now I'm changing that to congruent. And the reason for that is CP, CT, C. Corresponding parts of congruent triangles are congruent. So we could even mark that up here. This is congruent to this, and then this is congruent to that. So in the end, our first property that we want to consider is that if a quadrilateral is a parallelogram, then opposite sides are congruent. So let's practice this. The first one we looked at, the first property is that the opposite sides are congruent. So we are told in the instructions, each of the following are parallelograms. Either we're told it, or they will mark it for you, something like this. Now you know they're parallelograms, either by the diagram, actual marks, or because they tell you. If it's not told and it's not marked, you don't know. And the best you can say is not enough information. But in this case, we do have information. So what can we do? I can set up to say that this is congruent to this, or the same size. So I will set it up like so, plus 9. And then 1.5 steps later, I'll get my answer to be 16. You know you're right, because when I put 16 here, I get 48. Minus 7 is 41. Put 16 here is 32. Plus 9 is 41. And the same thing applies to these guys. That 5y is going to equal 2y plus 18. 3y equals 18, so y equals 6. Again, let's do a quick check. This here will give me 30. This here gives me 12 plus 18, which is also 30. All right, if you recall back in the day about parallel lines cut by a transversal, if we were only to focus on this pair right here and just consider the top and the bottom, and then consider only the AB here. So effectively, we're just going to ignore the CD, like so. If I have parallel lines cut by a transversal, what do I know about consecutive interior angles? These two are going to add to 180. They are supplementary. So these two angles right here are called consecutive angles. Why are they called consecutive? Because they come as you are going clockwise or anti-clockwise, if you're British. Then they are what come in order. A and B are consecutive. B and C are consecutive. C and D are consecutive. AD are consecutive. How do BD relate? Starts with an O. Opposite. They are opposite, and in the same, A and C are opposites. So what we're going to look at is the consecutive angles here. And here's what we find out. The following pairs of the polygon above, or to the right actually, are consecutive. So angle A and angle B and angle C and angle D, and lastly angle A and angle D. Those pairs are consecutive. Now this definition works true for every single polygon on the planet. So it doesn't have to be a parallelogram, it doesn't have to be, it could be a pentagon, etc. It's just as long as it goes in order. Not alphabetical order, but in order in the way they're written and drawn. All right, but if we combine that idea of parallel lines cut by a transversal, not only do we know something about their placement, consecutive angles, we know something about their size too. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Which brings me to a number of equations that can result. The measure of angle A plus the measure of angle B is equal to 180. So all four of these end up being true. Let's practice a little bit about what we just looked at, find the value of the variable. Well, quickly, we also need to make sure, and I'm going to put this in the definition, or excuse me, in the instructions, each polygon is a parallelogram. That should be written. If it's not, it's going to be hard to assume. So that's why I said that there. So these two here are consecutive angles. So quickly I see, and this again is how we show work, is we substitute into the formula like so, and then x is going to be 129. We don't need to write degrees because the degrees are already written up there next to the x. Properties. Property number 3, which again, these are just arbitrary numbers. They don't have to have any particular order. If a quadrilateral is a parallelogram, then the opposite angles are, if you had to take a guess, what looks to be true about angles B and D? They look congruent. Yay! The proof of that is almost the same proof that we did for the very first property. And since A and C are also opposites, those are going to be congruent as well. Essentially what you're doing is using CP/CTC, and instead of talking about the sides of the triangle, you're going to say, oh, this angle of the triangle is congruent. And then if you put a diagonal going this way, then those two are going to be congruent as well. So the key here is opposite angles are congruent. Opposite angles are congruent. And lastly, what happens to the diagonals? What happens to the diagonals? Well, this takes a little bit more proof, and we're not going to walk through the proof right now, but it's as simple as this, is that what happens is that the diagonals bisect each other. Bisect each other. So let's practice some of these, and let's look here. Please tell your partner on letter A, what's the setup for this? Again, for each of these, we're going to assume that these are all parallelograms. And in this one, 40 equals 3a minus 5, and then we can solve. equals 5y plus 4. Because the diagonals bisect each other, that's true. And then diagonals bisect each other, so the 3x plus 2 is equal to 23. And then we just solve accordingly. You can always check the answer. If we did solve for x over here, we get 3x equals 21, so x equals 7. And when I plug 7 back in, I get 21 plus 2 is 23, which matches there. Good, so because these guys here are opposites, and we want to primarily deal with the same variable, we can set up to solve for x. Now notice here, I could do that again. Oh look, this 3z is opposite 4y, but we don't want to use those because they're different variables. Well, what about these two, consecutive angles? Should we use those? No, we've got an x and a z. Oh, what about those two? Oh, x and a z. We have the... So there's a lot that's going on here that won't help us immediately. So what I'm going to do is set up for x. Now, once I have that x, I actually put it back in over here and then was able to use consecutive angles in step 3 to find z. Now, you have options after that, but I just chose, instead of doing supplementary, I just chose to set these two equal to each other. So I just said 3 times your z, 3 times my 36, is equal to the 4y. And then when you divide by 4, you get your 27. Not necessarily the order you have to go in, but the key is that we did have to find, this has to be your first step. The other ones are, well, step 2 is indeed, but you could have gone a different order after that. Please take a moment to summarize what 5 things we learned today about parallelograms. Definition goes in the middle, the properties go around, and they are complete sentences. Or they are the conclusion of sentences.